In the last tutorial, we produced all necessary audio tracks. In this tutorial, you'll learn how to segment them and create the necessary playlist files. Here's our agenda. We'll start with a quick overview of the structure of an HLS presentation, then briefly cover media playlists. We'll spend a lot of time on master playlists, covering both basic playlists and how to present alternate media, and finish with a quick look at how you can check your presentation with Media Stream Validator. There's a lot of detail in this presentation, and we'll move pretty fast, but you can download the playlist we're working on the Dolby site listed on the right, where you can watch the videos generated by these playlists. The site also contains extensive explanations and references and a link to download these slides. You probably know most of this, so I'll cover it pretty quickly. HLS presentations are controlled by two types of playlists: media playlists and master playlists. There's one media playlist for each audio or video stream in the presentation, and it contains a list of addresses for the content, either URLs for the segments or byte range requests. The master playlist contains a list of all available media playlists, organized so that the client can choose the appropriate audio and video files. Media playlists contain a list of media with a target duration and a uniform resource locator on the subsequent line. Here the media files are segments located in the same folder as the media playlist, so there's no URL, which is typical. Media playlists are usually created programmatically with a tool like Media File Segmenter or FFmpeg. Here's how you create a media playlist with Apple's tool, Media File Segmenter. This tool inputs H.264 encoded video in MP4 or MOV containers, and audio in AAC, AC3, and EC3 formats. Media File Segmenter outputs the media playlist, which has an M3U8 extension, an iframe playlist to use for trick play playback, which also has an M3U8 extension, a plist file, which provides file data for building the master playlist, and the media files, either segmented or single file if using byte range requests. Video will be formatted into MPEG-2 transport streams with a .ts extension, or as fragmented MP4 files with an MP4 extension. Audio will be formatted into elementary streams in EC3, AC3, or AAC formats, or as fragmented MP4 files. Here's the command structure for creating the file, shown on the right in verbose mode. The first line calls the program, again, Media File Segmenter. Target duration sets the segment duration, in this case 6 seconds, which is the segment duration recommended by Apple. Apple also recommends a keyframe interval of 2, which divides evenly into the segment duration. If you choose a different segment length, make sure your keyframe interval divides evenly into it. The file base is the target folder for the HLS media files. The utility won't make this for you, so you'll have to create the folder before starting. Base media file name is the name for the media segments, to which Media File Segmenter will add numbers for each segment. Index file is the name for the media playlist. iframe index file is the name for the iframe playlist. Log file is the name and location for the log file. Generate variant plist tells Media File Segmenter to create the plist file. Last is the name and location of the source file. Here are the outputs from the Media File Segmenter. On the far left are the file segments, here multiple segments in MPEG-2 transport stream format. In the middle is the media playlist file, which you'll use as is. Not shown is the iframe playlist, which you'll also use as is. On the right is the plist file, which is color-coded so you can more easily see the information that it contains. Later, you'll need to pull information like average and maximum bitrate from these files to complete the master playlist. To produce the 3 HLS presentations available on the Dolby site, we created one media playlist and one iframe playlist for each video file in the adaptive group. Plus, we created separate media playlists for all audio alternates in all 3 languages. Now let's move on to master playlists, and you can see a simple master playlist on the bottom of the screen. Master playlists list all the available media playlists and their URIs, including alternate audio tracks like those we're working with here. Master playlists also provide data like codec information and average bandwidth that lets the client choose compatible streams and switch between them during the presentation. You can create very simple playlists like the one shown below with an Apple tool named Variant Playlist Creator, but in reality, almost all master playlists are created by hand or scripted. Now let's examine the critical tags used in master playlists, starting with the Extreme Inf tag. As you can see, this tag identifies the variant streams available and provides information that enables the client to choose the most appropriate stream or switch streams when necessary. The attributes you should include with your EXT-Media tags are average bandwidth and bandwidth, codecs, resolution, frame rate, and closed captions. Note that the bandwidth and average bandwidth values should be the highest average bandwidth of any playable combination. This is critical when offering multiple audio versions, as you'll learn how to do in a moment. Codec, resolution, and frame rate help the client identify compatible streams. Closed caption informs the client when these are available, which they are not here. Now let's take a look at the tags necessary to deliver multiple audio alternates. The high-level goal is to provide several encodings of an audio program in a way that lets the client choose the highest quality alternative that it can play. In the playlists that follow, we'll offer Dolby Digital Plus 5.1, Dolby Digital 5.1, Dolby Digital Plus in stereo, and stereo AAC. The playlists will support both stereo and multi-channel endpoints regardless of codec, and support alternate languages. The simple concept is to provide several alternates and let the client choose the one that delivers the best possible experience. The mechanism we use to accomplish that is the EXT-Media Tag. The EXT-Media Tag tells the client that there are multiple alternates for audio, video, subtitles, or captions. In our case, audio codecs and languages. For each alternate, the master playlist defines a rendition group specific to that alternate using EXT-Media tags. You'll see what that looks like in a few slides. The snippet on the bottom of the page shows how the master playlist uses 4 EXT-Media tags to define separate groups for the 4 audio encodings. EXT-Media attributes include type, which is audio in this case. The group ID identifies the group and ties it to a rendition group later in the master playlist. The language attribute defines the language, with the language name provided in the native tongue so the viewer can easily select it in the client. The default identifies which rendition the client should use to play by default, while AutoSelect identifies which rendition should play in the absence of user preference. In this case, the default setting is yes for all options because the client will scan these 4 lines and play the first compatible format. Finally, Channels identifies the number of audio channels in the content. Looking at the snippet on the bottom, you see we have 4 groups, all audio, named after our 4 audio encodes with the appropriate channel count. The URI shows the location for the media playlist associated with each audio file. Operationally, each alternate audio type will have a separate rendition group identified via the group ID. Each alternate within that group is defined by the EXT-Media tag, which contains codec-specific attributes that allow the client to determine playback compatibility. You can get codec IDs from the plist file, and codec names for audio are included in the slide for your convenience. As you learned above, each EXT-Media tag must include max bandwidth and average bandwidth and the location of the media playlist files for the video. Ordering of the EXT-Media rendition blocks matters, as the client will play the first compatible rendition block. If you have Dolby Audio in your presentation, you want to list those renditions first. During playback, the client retrieves video segments using the EXT-Media tag, audio segments using the EXT-Media tag, and synchronizes and plays the two. Unlike the media playlists, master playlists have to be completed by hand or are scripted. You'll need the media and iframe playlists and data from the multiple plist files. You can create the separate rendition groups with an Apple tool called Variant Playlist Creator, but you'll have to add the group ID and audio codec and manually update the bandwidth and average bandwidth. Your call as to whether you'd rather start from scratch or use Variant Playlist Creator. Here's the high-level presentation in the master playlist. The top section includes the alternates defined by the EXT-Media tags. Then are rendition groups containing all 8 video files for each EXT-Media group. The player will play the first compatible audio codec found in a group, so list them in the order shown. Last on the master playlist is a single iframe list. Here's the EXT-Media tag for the Dolby Digital Plus 5.1 surround group and the associated media grouping defined by the EXT-Media tag. They are tied together by the group ID. Note that the bandwidth and average bandwidth will change for each rendition group. For the figures listed in this rendition group, you need to add the average bandwidth for the video files and the average bandwidth from the 5.1 Dolby Digital Plus 5.1 surround audio files. The audio values will obviously change for each rendition. Here's the EXT-Media entry in the EXT-Media rendition group for Dolby Digital 5.1 surround sound. Here's the EXT-Media entry in EXT-Media rendition group for Dolby Digital Stereo. Finally, here's the X-Media entry in the Extreme Inf Rendition group for AAC Stereo. Now let's cover how to present multiple languages. Here we're working with audio recorded in 5.1 surround with English, Spanish, and Chinese narrations. In each language, we have audio encoded in Dolby Digital Plus and Dolby Digital 5.1 surround formats, Dolby Digital Plus Stereo, and AAC Stereo. So each of these audio formats will have 3 X-Media options, one for each language. You see the 3 X-Media alternates on the bottom of the slide, showing only the Dolby Digital Plus 5.1 entries. Language is specified using the language code, with the name spelled in the native tongue, and the default is set for English. However, setting Auto-Select to Yes lets the client auto-select Spanish or Chinese if the system language is set to either of those languages. Using this scheme, English will play by default, but the viewer can manually select other languages. Here's what a viewer watching on an iPhone would see. The audio codec is selected automatically and is therefore abstracted away. All the viewer needs to do is select the desired playback language. In the master playlist, the top section includes the alternates defined by the X-Media tags, including all 3 languages for each audio codec as shown above. As noted, it's okay if some of the languages are only available in stereo, for example. You would just omit the X-Media entries for the 5.1 audio and keep only the 2 stereo entries. The rendition groups would have the same entries, but the data rates would have to be updated for the highest values of any of the audio streams available for that rendition group. So if the average bandwidth for the Spanish files was higher than English, you would update the entries. The iframe list would remain the same. Once you have all the content encoded and segmented, and all playlists created, you can upload them to your web server. Obviously, all the paths in the master and media playlists must be accurate, or the presentation won't work. One great tool for checking this is Apple's Media Stream Validator, which reads through the master playlist and verifies the availability of all playlist and media files. You see some additional resources from Apple on how to validate your HLS presentations. If you're integrating Dolby audio into your presentations, you should definitely have a look at the Dolby blog post. Finally, for more information about HLS encoding in general, check out Apple's HLS authoring specification at the URL shown. So that's it. Dolby Audio provides enhanced clarity, easy-to-hear dialogue, consistent volume, and surround sound when played on a 5.1 or 7.1 channel system. Now you know how to deliver Dolby Audio via HLS to all Apple devices that support it, including iOS devices, Macs, and Apple TV units. You also know how to produce a playlist that enables automatic fallback to AAC Stereo for clients that don't have Dolby Audio support. I'm Jan Ozer. Thanks for watching.